you are eager to dive into the practical AI course, you are in the right place. Welcome to the third episode of this 8-part AI course, where I will guide you through the essentials of AI and machine learning. AI is an incredibly exciting field, empowering innovation like chatbots or autonomous driving cars. Whether you are just starting with AI or trying to sharpen your skills, this video is exactly for you. Don't forget to hit the like button, smash subscribe, because we're gonna explore a project about spendings of customers using unsupervised learning algorithm K-means. This is how the project will look like. In this project we will focus more on building our own functions than importing these privileged functions from the libraries and modules that we can find on the internet. In this project we will get the customers. This will be our input dataset with the two features: spending of the customers and age of the customers. And the goal of this project is to create a model that will group similar customers to one cluster and another similar customers to another cluster, and so on. We will specify the number of clusters and we will do some data preprocessing before that. I will show you what is feature scaling. We haven't done that yet. Then we will do the programming from the scratch of all the functions. We will use these functions to create the algorithm, and then we will visualize the result. So this episode is very exciting. Let's dive in. Together we can make history. Before we start coding, I will tell you what is unsupervised learning and clustering. Unsupervised learning is a type of machine learning where the model is trained on a data that doesn't have labeled outputs. This means the model only sees the inputs and has to find patterns and relationships in the data on its own, instead of predicting specific outputs like the price of the house. The model tries to group similar data points or find the hidden structures within the dataset. In this video, we are focusing on the K-means clustering. That means we will specify a number of clusters and the algorithm will try to fit the data into these specified clusters. I forgot to mention that all the important links will be in the bio, like the link to my GitHub repository where you can find the code. Before we start with the code, let me do one more thing. We need to set up the project. It is very easy. You just open your file explorer somewhere, create a new folder. Where is it? New folder, clustering. Open this folder, copy the path by clicking here, Ctrl+C, open your favorite terminal, wait a minute, write cd, that stands for change directory, paste your path to that directory, press enter. Here, if you haven't installed Jupyter Notebook, as always, write pip install notebook. But I'm pretty sure it's third episode that you have installed Jupyter Notebook already. So write Jupyter Notebook and press enter. It will open an instance of a Jupyter Notebook in your Internet Explorer. Here it's that your folder. You can create a file, new notebook, enter Python, and here we will write all the code. As you could notice, we won't download any dataset today. The dataset will be only this simple few lines of the code, because our algorithm will be more difficult today, so I don't wanna make like too hard times for you. So let's go straight to the code. Open back the Jupyter Notebook. First, what we need to do is to import the libraries. Shift enter to run the cell, or this run the cell, this arrow. Here you can switch between code and markdown. Now I need to code. Import the libraries. As always, the pre-default libraries are the NumPy, Pandas, and Matplotlib. Import NumPy as NP, and import Matplotlib pyplot as PLT. matplotlib.pyplot is for visualization of data, and numpy is for numerical computation. And we won't use pandas this time because we don't need to download our dataset, it will be straight in the code. But it's very good to know that pandas exist. It's used for the dealing with the data frames, CSV files and so on. Next, the cell will be the dataset itself. So I will write another title, dataset, this little arrow or shift enter. And to create the dataset, just go to my GitHub, copy these 3 lines, code, copy and paste it to your working directory. We have the dataset. This is not the markdown, this should be code. Run the cell, run the cell. And as you look as the customers, the first value is the spending of a customer, and the second value is his or her age. The difference between the ages is like very small, it makes sense. And the difference between the spendings can be like pretty high. For example, there's like this customer spent only 70 euros and this one 23,000. That means the range of the spendings are much higher than the range of the age. That means that the spendings could have more impact on the algorithm than the ages. And we don't need that, we don't want that. All the parameters of our algorithm need to have the same impact on the model. To change this, I will introduce you a new topic, the feature scaling. This feature scaling can be done in different ways, but for now I will use a standardization. It will count the mean of these values, the standard deviation and all the other values you can see in this equation. And if you want to know more about this equation and standardization, there will be a link in the bio. You can dive deeper into this topic. All you need to know is you will just count these values and somehow return this customer dataset. The values will be from around -3 to 3, and the values will have the same impact. You will just change the range of the values to have the same impact. For this feature scaling, I will import from sklearn pre-processing import standard scalar function. You can find everything about this function in the sklearn. Here is what does this class do, all the methods, descriptions of the methods, use cases, all the stuff are here. I will come back to our code, create an object of this standard scalar. I will name it scalar, build the instance of this class. We don't need any arguments in this class. I will use the method fit transform form our data. It means it will learn and also transform our data, and I will store it back to our variable customers and print out the customers. Here something is wrong. I know what is wrong. I cannot import. I have to from this import that, and you see our values change the range. For example, this like fourth value is like pretty low comparing to this one, so it's the minus. You see the range change, but the relation between the data hasn't changed at all. Now all the parameters, in this case 2 of them, of our customer's dataset will have the same impact of the training of the dataset. The next thing is the means Supervised Learning Algorithm. Here I will do markdown, shift enter. How does the k-means clustering algorithm work? For example, we have this dataset visualized on the graph, and we will group the points that are similar to the same group. We call this group clusters. To make this group, we need to somehow count the distance between the points. I will explain this algorithm step by step as I will be coding. So the first step is that Euclidean distance between 2 points to count the distance between 2 points. I will define a function for this, name it Euclidean distance. Here will be 2 points, P and Q. This distance is normal Pythagoras theorem. Just count one coordination minus the first coordination of 1 point minus the first coordination of second point to the power of 2, sum up of all these divisions and make a square root, as you can see on this picture. I will start with I will do it more generally because it is better to program like that. So numpy array of 1 point minus the numpy array of the another point, the second one, and this will count the differences between all the coordinates, between the x coordinate minus the x coordinate of the q, y coordinate of the p minus y coordinate of the q. And here what we need to do, we need to make here num like to the power of 2, and also we need to sum up all these values, numpy sum. The last thing is to make the square root. Numpy square root is. You can try this function on like simple data, print out Euclidean distance of 2 values. First one will be like 1 1, like x value will be 1 and y value will be 1, and the second value will be 2 2, so it should be like 1.4 something. There is one missing. Parentheses, enter 1.4 because it is like 1 1 2 2 and the Pythagoras theorem of this value. So it is working, or you can imagine it like this one. So you will first coordinate minus the first coordinate, second point times the same equation plus the second coordinates, and we will do sum up of all these values, all how many like dimension has the points, and then we will do the square root because on the other side of equation is something to the power of 2, and to make the distance you need to square root the equation. That's all. The second step of this algorithm to initialize centroids. Centroid is a center of a cluster, but initially the exact center of our cluster is unknown. So we select random point from our dataset and it will be defined as a centroid for each cluster. There will be as many centroids as many clusters we will define, as you can see in the picture. You can pick a random number or you can pick a random point from your dataset. It's up to you. I think it's better to do random point somewhere, but in this project we'll pick a random point from our data. I will define a function also for this initialize and draw it. Here I will put the dataset and number of clusters. For this initialization, I will use the numpy function random. I will put here the seed to produce the same result as you have for 2. Here I will do the numpy random choice from our dataset, from our customers, and the size will be the number of clusters. And we don't need to pick the customer, we need to just pick the number, like the index of that customer in our dataset, and we will store it into the centroids indexes. What do you call this? I will return then the centroids from our customers, just writing the dataset, and the indexes will be the index. Here I will call the function the initial centroids are equal to the function centroids the dataset will be the customers, and the number of clusters in our project will be 3. Print out the initial centroids, give enter. And as you can see, the initial centroid is this point, minus 79, this one, and 1.63 is this. So these are the 3 initial centroids. The next step of this algorithm is to assign all the data to the nearest clusters. For assigning the points into the clusters, I will do another function, define assign clusters. Here I will put the dataset, the centroids, and write the function. This function I will, in the main algorithm, I will use this function in every iteration. Here I need to create the clusters. Clusters I will create through the list comprehension. I will create that many lists for the list in range, the length of the centroids. So the length of the centroids is 3. Here, in range is to create an iterable object, and I will create empty list that is immersed in bigger list, so it will be a 2D list of lists with the number of the list, how many points we have in the centroid. So for every centroid there will be 1 cluster. If you have any more questions, you can stop the video and think about that more. Now I will iterate over every point in our dataset to this altered dataset. For customer in customers, I will count the distance from first centroid. It will be equal to the, I will use the function to count the distances. Euclidean distance of the point, the customer itself. So in the first iteration it will be like this customer, the first one, and the first centroid. And the centroids are points, so it is like we will put them here as the parameters, so they are not called initial centroids, but centroids. First centroid, the first one will with index 0, we will count this distance. The second one I will do the same. The distance from the second centroid will be equal to this distance. Copy paste of the second centroid. Copy paste from the third centroid here. The Euclidean distance of that same point from the third centroid. Here I will define the empty list, not empty list, but the list distances. The first value will be the first distance, second value will be the second distance, and the third value will be the third distance. From these distances I will count the closest one, so closest centroid will be the smallest value from these distances. We can use another numpy function for this, argument minimum from the distances. Here I will just edit some letters. Okay, fine. Now we got the index of the closest centroid, and with this closest centroid, clusters on that index of that closest centroid append new value, which will be the customer itself, and I will return these clusters after one iteration. Okay, it should be working. Now let me test this. So clusters are equal to assign clusters function with the customer dataset. Centroids are the initial right now, but I will use another centroid in the main function, and I will print out the clusters. We got only one customer assigned to this function, and the reason is why, because we got the last one. We got the last one because in this for loop we have to, in every iteration, assign that customer, not just count the distances and then only assign the last one. So use the tab to make the spaces here, shift enter, save the code, run it again, and run this code again also. We got the main 2D NumPy array. The first cluster is from here all the way here. No, it is only all the way here. This is the first cluster. Second cluster is until here, and this is the last cluster of the points. These points are random customers. We don't have labels for them, and we also don't have the indexes, but we could have like names for this the data points and that stuff. But this tutorial is focused on the implementing the k-means from the scratch, and you can always just compare these points to the dataset. Like this is the first point, and this means like 23,054 years. Or you can alter the code and learn something new for yourself to have more and better readable code that visualize the data better. That can be like exercise for you. The fourth step of this algorithm is to update the centroids or reinitialize the centroids. The next we will reinitialize the centroids by calculating the average of all data points of the clusters, as you can see on the picture. For this I will define a function update centroids. You are guessing right, I need to put all the clusters here, clusters with the assigned points. Create here the list of new centroids, the empty list, and for every subset, so this is the cluster 1 until here, from the beginning until here, this one, and we need to count the mean of the values on the columns. So mean of this one will be mean of x values, and this and this will be mean of the y values. And this is how we will define new centroids for every subset for our 3 clusters. For sublist in clusters, use the NumPy function mean of the sublist. On the axis will be equal to 0 to count it on the columns. The 1 will count it on the rows, and it doesn't make any sense in this case. And I need to store this new centroid. I need to store this new centroid, or otherwise it is the sublist mean. And I will store every value for every centroid into the empty list. This empty list will have 3 values after this for loop. Sublist mean. The sublist mean, as I wrote here, is this new centroid. And I will return new centroid. Here I mistake. Press enter. I can try this function on new centroid. It's equal to update centroids, the clusters, and print out the new centroid. Hit enter. The new centroids, or the mean value, is this, this, and this. And this is like the mean value of the all points that belong to the cluster. The last and 5th step of the k-means algorithm is repeat the assign of the clusters and creating new centroids. If the new centroids are the same as the old centroids, the algorithm is in the end and the clusters has been assigned to the final value, or we can iterate to the number of iteration we specify in the parameter of the last function. I will initialize right now. Here I will write the final function define k means algorithm. That's our model in this case. There I will specify the dataset, number, clusters, and max iters, which will have default value of 100. The first thing I need to initialize my centroids, initialize centroids in the dataset, and for y in range max iters, I will assign the clusters like every iteration. First thing, I have the initial centroids, so I will assign the clusters with these initial centroids. I will rename these initial centroids for centroid in this function only, and then I need to create the new centroid. I have the initial centroids or the centroids. Now to create the new centroids, I will use this function update centroids, and here the customers is our dataset. Also clusters here. Okay, that's okay. And if the new centroids are the same as the centroids, we don't need to iterate all 100 iterations. I will use some numpy function for this. So if numpy all numpy array of the new centroids, so if the numpy array of new centroids, like every element, this all function is the same as numpy array of the centroid in the last iteration or of these initial centroids are the same, I will simply break the function. And then if it's not the same, the centroids in new iteration will be equal to the new centroids. And in the end of this function, I will just return the clusters. Yes. And also I will return the centroid. This three I can just specify with this parameter, number of clusters. Here I'm missing one letter. Run the code, open new cell, specify the number of clusters. Here create the variable clusters and centroids, and I will run the training process. K means algorithm customers as data set, number of clusters as the number of clusters, which will be equal to 3, number of clusters, and max iter is the same, 100. Here I will print clusters, print out a new line, and print the centroid. The centroids are this, and the final clusters are this one. I will check how many iterations this algorithm goes through. I defined the data points like very close, like every data point makes sense, be close to the same age, like the 32 is like spent of 10 euros, 34 is like 70 euros, so I will see if there will be like many. I don't think so there will be like many iterations, maybe only one. So but it's just to showcase you how does this algorithm is created from the scratch. Okay, there are only 2 iterations. Can I print out the centroids? I will print out the clusters in every iteration with the new line. The mistake, it is correctly written, but the name is clusters, not the cluster, so I will just do it like this. Oh. This really divided into that clusters for after one iteration. But that's not a very accurate example, our dataset. But now you understand how the k-means algorithm works, and you can build these functions from the scratch for any dataset. And also it will help you to understand how to build the machine learning algorithm from the scratch, that basically behind every default, the basic algorithm is only mathematical function. And it's not really that difficult. And you need to understand this to build upon on this knowledge to create something more difficult. The last thing will be the visualization of our data. So visualization, with enter. To visualize our algorithm, I will use the code in my GitHub. I won't write the matplotlib code by my own, because it is not very important for this tutorial. This is only for the visualization of the data. So I will define some global variables, then define the function to visualize our dataset after the training process. And also we need to call this function. Here I will call this function, press shift enter. Now shift enter, and you see the points were very close to each other. So if we initialize the center, it's like here, here, and here, it will automatically assign them on the first iteration. That's not very good. You can maybe try to change the random initialization of the centroid. Where is it? Initialize of centroid. I will change the seed to, for example, 13. Run the whole code and see what happens. And now there were many more iterations. Print y. Oh, many more iterations means like one more iteration, but the clusters look differently because the initial values were different. I don't think that's very good. It should produce the same result every time. Okay, every day we learn something new. I just discovered that this is a new feature. This is a known feature that if you initialize the data points like differently, the first centroids, you can get the different result. And it is, on one hand, it is a feature because it is a variety of the result, but on the other hand, you, in some cases, in many cases, you don't want to get like different results only by the initial values. So it's 50-50. I would say it's more like drawback than the feature. And if you wanna do like some mapping of these values, here the customers doesn't have like the names somewhere. So if you wanna do like mapping of this value to this value, I have here on the GitHub the static mapping. It is just this directory. You can copy it here and save it, and maybe alter this code a little bit to display this name next to the point. But it will take a long time, and the main point of this algorithm is that I show you the k-means algorithm and how to build it from the scratch. So quick recap, we downloaded all the necessary things. This was our data set. We learned what is a feature scaling. It is the scaling the feature to the same range. So every argument or every feature of our dataset has the same impact of our algorithm, of our model. Then we did the unsupervised learning algorithm k-means from the scratch. The most important thing is that behind this algorithm is a mathematical function. The distance between 2 points, and we do some iteration of the assigning centroids, the points to the clusters, and we iterating over it. You've done it yourself, so now you understand, and then we visualize the result. It is just a small bonus to this video. I hope you enjoyed this tutorial. If you have any questions, leave them in the comment section. If you wanna improve something in my videos, you wanna see something new, some new concept, write it also in the comment section. I hope you like this tutorial, you learn something new. You can hit the like button, smash subscribe, share with your grandpa this time, not grandma, and all your friends also. And have a beautiful rest of your day. Peace.